Now let us take up this problem. We are given that the LCM and HCF of two numbers are 120 and 6 respectively. We need to find their product. So in this case the LCM is 120 and HCF is 6. Now if you are able to recollect the formula, LCM multiplied by HCF is nothing but the product of the two numbers. So what do we need to find? Product of two numbers. So in which case this is LCM multiplied by HCF, that is 120 multiplied by 6, which is 720. Next problem, we have to find the LCM and HCF of 30 and 45. So if you are able to recollect, the first step we need to do is to factorize both the given numbers. So first of all, what is the prime factorization of 30? So 30 can be written as 2 multiplied by 3 multiplied by 5. Similarly, 45 can be written as 3 multiplied by 3 multiplied by 5. Now to find the HCF, we identify whatever is common to both. So in this case 3 into 5 and 3 into 5 is common. So HCF is nothing but 3 into 5, which is 15. In the case of LCM, this is so 45 can be written as 3 squared multiplied by 5. So we need to ensure that in the LCM all the factors are covered. So 3 squared multiplied by 5 will be present along with it. So in 3 squared multiplied by 5, 3 multiplied by 5 is already there. All that is missing is 2. So we simply multiply it with 2. So this is 2 multiplied by 9 multiplied by 5. 2 multiplied by 5 is 10. Multiplied by 9 would be 90. So the LCM is 90 and the HCF is 15. In the next problem, we need to convert improper fractions to mixed fractions. So two improper fractions are given. I need to convert them into mixed fractions. So first of all, 29 upon 12. So when we divide 29 by 12, in this case the remainder is 5 and the quotient is 2. So I can rewrite 29 by 12 as 2 5 upon 12. So here is the quotient, here is the remainder, and this is our divisor. So similarly 39 by 8. So in this case 39 by 8, the quotient is 4 and the remainder is 7. So this is 4 7 by 8, because 4 multiplied by 8 is 32 and 32 plus 7 is 39. So this way we can even cross check. Once we have converted to mixed fraction, if we want to convert it back to the improper fraction, we simply multiply the divisor by the quotient and add the remainder. Because if you are able to recollect from your earlier classes, dividend is nothing but divisor multiplied by the quotient added to the remainder. Next we have a very straightforward problem. We simply need to find the product of 31.45 and 6.7. So what do? We simply multiply 3145 by 67. So we simply ignore the decimal point and first we multiply the numbers. So the resultant is 210715. You can check with the multiplication. And once we get our result, we will see how many decimal places, after how many decimal places we need to put the decimal point. So in this case, the resultant will have 2 plus 1, that is 3 decimal places, this 3 digits after the decimal point. Because 31.45, we have 2 digits after decimal point here and 1 digit 7 after the decimal point here. So in the final resultant, I'll have 3 digits after the decimal point. So the answer is 210.715. Next, we have an interesting problem. We are given 4 fractions, and of these we need to find which of them are recurring decimals. So if you remember from the earlier lessons, so for it to be terminating, so a decimal could either be terminating or recurring. Now for it to be terminating, the denominator should have a 10 in it. What do I mean? The denominator should have only factors of 2 and 5. These should be the only prime factors in the denominator. So if we take the denominator and this denominator, we take it in the simplest form of the fraction. So in this simplest form of the fraction, the denominator should have only 2 and 5 as the prime factors. In case there is anything else besides 2 and 5, it would be recurring. For example, say 19 by 81. So all we need to do is check first whether it is in its simplest form. It is. So 81 can be written as 3 power 4. So it has prime factors other than 2 and 5. So this would be recurring. Alright. Next we have 13 by 40. So this is also in its simplest form, and we don't bother about the numerator, we just check the denominator. So the denominator is 40. 40 is nothing but 8 multiplied by 5, that is 2 cube multiplied by 5. So it has only 2 and 5 as the prime factors. So this is terminating. Now what about 25 upon 64? So we are just bothered about 64. 64 is nothing but 2 to the power of 6. So this would be terminating. What about 125 upon 240? So in this case, 240 can be written as 2 to the power of 4 multiplied by 3 multiplied by 5. So other than 2 and 5, I have one more extra 3. Because 3 is there, this will be recurring. So in our example, 19 by 81 is recurring because we have a 3 here, in the 3 as a prime factor in the denominator. 13 by 40 is terminating decimal, 25 by 64 is terminating, and 125 by 240 is recurring. So we are asked what are the recurring decimals. So 19 by 81 and 125 by 240 are the recurring decimals.